Welcome to another chemistry lesson. This time around we're looking at a wonderful subtopic, which is electron configuration. So electron configuration, by definition, it is the arrangement of electrons in the shells of an atom. It is the arrangement of electrons in the shells of an atom. So that is what we mean by electron configuration. Now, this word shells, we want to know what is it all about after we've learned about electron configuration. So electron shells, by definition, this is a concentric rings around the nucleus. So what is the alternative term for electron shells or shells? It is energy levels. So the other word for shells is energy levels. So another definition, if you like, for shells, it is just the path taken by an electron. Now, this is the diagram to represent the shells. This is the nucleus we're talking about here. This is the nucleus. As we can see, it's a nucleus. Now, the rings around the nucleus is what we call shells. So the first shell is called the K shell. The second shell is called the L shell. The third shell is called the M shell. The fourth shell is called the N shell. Now, after looking at that, we have about 4 shells that are here. So these shells, or energy levels if you like, each has the maximum number of electrons they can accommodate. We are saying that electrons are found where? In the shells. And in these shells, there is the maximum number they can do what? Accommodate. Okay? So now, note the maximum number of electrons each shell can accommodate, meaning or can have, is given by the formula 2 n to the power 2, 2n to the power 2, whereas n is the number of shells, whereas n is the number of what? Shells. So now we want to use the formula now to see if how many electrons does K shell have. So K shell is the first shell, meaning n is equal to what? 1. Remember, n stands for number of what? Shells, and the K shell is the first shell, so meaning that is 1. So now, using our formula, we'll say 2, then let me even do this. So 2, then n to the power 2, then we say 2, we substitute where there is n, so we say 2 times 1 to the power 2. This is the same as 2 times 1 times 1 here, times 1. That's what it means. 1 to the power 2, it means 1 times 1. Then we'll say 2 times 1 times 1 gives us 2 electrons. So meaning, what are we saying? The first shell contains how many electrons? 2. So we now look at the L shell. So L shell means that the number of shells is equal to what? 2. So we'll go back to our formula, okay? Then we say 2, then here we say what? Times 2 to the power 2. Then this is the same as 2 times 2 times 2, which is going to give us 8 electrons. So what are we saying? The second shell should contain how many electrons? 8. So for M shell, we are saying that n is equal to what? 3. So we'll come with our formula 2n to the power 2. This is 2 times 3 to the power 2. Okay? Then this is the same as 2 times 3 times 3. Then our answer now becomes 18 electrons. 18 what? Electrons. Okay. So go to the last shell. So our formula is 2n to the power 2. Then this is 2 times 4 to the power 2. It's the same as 2 times 4 times 4, which is going to give us 32 electrons. Okay, so that's where we end here. Next time, in the same topic, we'll now look at how to write the electronic configuration by writing, and also by what? By drawing. Otherwise, till next time, from now it's bye-bye.